Welcome to this explainer. Today we're taking an incredibly fascinating journey, going from chaotic, messy raw inputs all the way to clear, compelling visual stories. If you've ever stared blankly at a massive spreadsheet or a jumbled list of numbers and felt completely overwhelmed, you are absolutely in the right place. We're going to demystify the whole process.
Because let's be real, we live in an absolute age of information. From the literal second you wake up to the moment you go to sleep, you're generating, consuming, and interacting with data. But in its rawest form, it's just noise. It's total chaos. So our goal today is to empower you to actually tame that noise and turn it into a crystal clear signal.
All right, let's look at our roadmap. First up, making sense of data. Then, collecting and organizing it, before we move on to visualizing with pictographs, and finally, scaling everything up to bar graphs.
Starting right off with Section 1, making sense of data and the inherent problem of chaos. Before we try to organize a single thing, we kind of need to figure out what we even mean when we drop the word data.
We hear it as a buzzword all the time, right? But it's not just complex computer code. Data is literally any collection of facts, numbers, measures, observations, or descriptions that convey information, whether it's listing out shoe sizes, the weight of students in a classroom, or just tracking your friend's favorite colors. All of these collected facts act as our raw material. And here is the initial problem we always run into. Imagine someone like Navia, who went around asking everyone she knows what their favorite game is. She's totally thrilled that she did the hard work of gathering all that info, but the resulting list? It's basically unreadable chaos. It's just a dense wall of text, name after name, game after game.
You can't just glance at a massive paragraph like that and instantly spot the winner. It creates this huge gap in our knowledge and forces us to ask, how do we actually extract the truth from this mess? If we want to know whether cricket or kabaddi is the absolute favorite, reading it line by line is super frustrating and, honestly, pretty prone to errors. We need a way better system. Which brings us nicely to Section 2, collecting and organizing, or simply put, bringing order. This is where we move from just casually gathering information to actively, purposefully managing it. To solve the chaos, we organize the raw facts into neat columns and track the frequencies. Think about teacher Shreen Elish, who needed to figure out which sweets to buy for a New Year's celebration. Instead of writing a massive paragraph of what every individual kid wanted, he set up 3 simple columns: the sweet name, a space for tracking, and the final count. Instantly, the classroom's preference takes on a real, structured shape. And the real magic happens with the tallying technique itself. It brilliantly breaks down a foundational math concept into 3 super digestible actions: ask, mark, and bundle. By drawing that satisfying diagonal line on the 5th vote, you instantly create groups of 5. This lets your brain skip count incredibly efficiently. When you add them up, you aren't counting one by one anymore. Your brain just skips along. 5, 10, 15. It's literally a built-in human algorithm. Alternatively, simply organizing raw numbers into ascending order is a massive game changer. Take students' shoe sizes, for example, without using any fancy charts whatsoever. Just by putting those numbers in order from size 3 up to size 7, the patterns naturally emerge. You can instantly spot the smallest, the largest, and exactly where the sizes are most heavily concentrated. Now that we have successfully ordered our numbers, let's hit Section 3, visualizing with pictographs. Because what if we want to present this information without using digits at all? Enter the pictograph. It's a fantastic, suggestive visual tool that lets us understand frequencies, like modes of travel or maybe sleep habits, with just a single glance at a picture. You see, our brains are entirely hardwired to process visuals way faster than text. So when you see a row of little drawn cars next to private car and a much longer row of little walking figures next to walking, you get the comparison instantly, no reading required. The absolute most crucial point to remember here is the idea of scale. Because one drawn object might represent a single person, sure, but it might also be scaled up to represent 10 people. If a school has hundreds of students, you obviously aren't going to sit there and draw hundreds of little stick figures. By changing the keys so that, say, one smiley face equals 10 children, you keep the whole graph clean, compact, and super easy to read. But hey, pictographs absolutely have their limitations. If a class has exactly 27 students and your symbol equals 10, drawing precise fractions of a tiny picture gets really messy really fast. Like, how do you clearly draw 7/10 of a bicycle or 0.3 of a smiley face?
When dealing with highly specific, granular data, the charming visual of a pictograph suddenly becomes a huge hindrance.
And that perfectly tees up our final section, Part 4, scaling up to bar graphs, so we can finally visualize the complex stuff and overcome those pesky limitations. When we're observing massive macro data, think about 1,200 cars passing an intersection during the morning rush hour. A bar graph becomes our ultimate scalable solution. The vertical axis gives us precise numeric intervals. We can accurately map out that at 6 a.m., traffic was incredibly low at just 150 vehicles. But by 7 a.m., it shot up to an enormous 1,200. And the best part? No drawing half cars required.
This just brilliantly illustrates why bar graphs are so essential. Their uniform structure and visual exactness completely eliminate the clunkiness of drawing hundreds of symbols. Because the width is uniform and the spacing is exact, your eye only has to measure one single thing: the height. It allows for an instant, mathematically precise comparison across multiple categories, literally no matter how huge the numbers get. So, as we officially wrap up this explainer, I want to leave you with a thought to help you start looking at the world like a true data scientist. The next time you're reading a dense news article or even just watching a busy intersection, ask yourself, how would I map this chaos into a clear, compelling story? Because trust me, behind every single jumbled list or chaotic scene, there's a clean, visual truth just waiting to be uncovered.